Okay, so we're going to work on graphing lines. So first we'll start with the slope. What we're going to look at is how to calculate slope given 2 points. We can use the formula. So what I showed is most people probably teach it with y2 minus y1 over x2 minus x1. It doesn't matter as long as you're consistent. So sometimes I'll put y1 minus y2 over x1 minus x2. There's other people that say delta y over delta x. That's just change in y. That's from science. Change in y over change in x. So right here, what you're going to see is a change in y over change in x type. So you could graph the 2 points, calculate the distance across, straight across, the distance up and down, ignoring signs for the time being. So it's 8 is the change in x, 6 is the change in y, or you can call them rise over run, 6 over 8. And then you have to determine if it's positive or a negative slope. A slope is positive as we move left to right if a particle along that segment would go up as we move left to right. Okay. Negative would be if we move left to right, it would go down. So 6 over 8, we could reduce it to 3/4. So that's what we're talking about with slope, rise over run. Some special cases is when your line is horizontal, its slope is 0. Now there's a difference. A slope of 0 is actually a slope. Slopes equal to 0. It has a value. When you have a vertical line, the slope is undefined. We can't do it. We can't calculate it. It does not exist. So for us, for our purposes, when a line has a slope that's undefined, we know it's vertical. When a line has a slope of 0, we know it's horizontal. Now, most of our lines will have some sort of tilt to it. A positive as we move left to right will go up. A negative slope as we move left to right, particle would decrease. So that would be a negative. So there's your 4 types. So this is just showing you the algebra. Okay, I chose to put y1 minus y2. If you look at the coordinates, the second values are the y values. They go on top. 3 take away 7. Some people will be 7 take away 3, but you just got to be consistent. I'm going to go 3 take away 7 on top. Negative 5 take away 1 on the bottom. Now, we should never stop at a double negative. We should always, 2 negatives, we should make that a positive. Reduce when possible. Basically, you're going to factor out a 2 from the top and bottom to leave you with 2/3. So what I'll stop doing is I won't continue to write down the formula after I've memorized it. If you just show us the values substituted in proper positions, you'll be all set. So I know that on top is the y values subtracted, and on the bottom then is the x values subtracted. Okay, factored out of 2 again. Right here, I'm just showing you what it would be if it was on a graph. So I counted the change in x, which was 10, change in y, which is 6. So I would put 6 over 10, and then afterwards determine that d to c is a negative slope as we move left to right. Now, some folks would mistake this. They think, oh, well, we got to move from C to D. That's the wrong direction. That's moving right to left. We don't do it that way. We move left to right. It is decreasing as we move left to right, so it's going to be a negative. Okay, so then that's the end of our slope discussion. Now we have equation of a line. So we have slope-intercept format. This is what you're very used to. So I'm not going to spend too much time on that. Basically, what happens is students learned mx plus b format, right? So b is the y-intercept. So you start at 5 up on the y-axis. Why is that? Well, if you were to plug 0 in, right, that would go away. Y would equal 5. Pretend that 3x isn't there. Y would equal 5. So we're actually plotting the point 0, 5 as our first point. And then from there, we're going to move up 3, right 1, and then make a new point. Up 3, right 1, make a new point. So I'm estimating, again, I don't have graph paper here, but that's, say this is 5 on the y-axis. From there, I'm going up 3, right 1, up 3, right 1, to keep creating new dots, new points. We could also go down 3, left 1. Okay, another example. So we're going to start at 4 on the y-axis. From there, I go down to right 5. So this one was slope-intercept. The new format for this course is going to be point slope. Okay. So the one we previously learned was slope-intercept. This one is point slope. All right. The trick on this is you're still seeing y equals mx plus b sort of, but now we're instead we're going to have our point directly here. All this means is we're going to start our graph at a different point. In this case, it's going to be 2, 5. So we'll keep looking at that. So what I try to teach my students to make it easy is look at the value that's in here with x, okay? And it's going to be the same number, the opposite sign. So if it says subtract 2, it's going to be 2. Subtract 5, so it's regular 5. Okay. Now, after we plot the 0.25, we're going to apply a slope of down 1, right 2. So there's my 0.25, and from there, I'm trying to go down 1, right 2. Okay, we're on to the next one. So I was going to have you guess as to what the point was, but it's going to be x is 1, y is -3. Basically, if we were to enter in 1 here and -3 there, the whole equation would be 0 equals 0. Okay, from that point, we're going to go up 4, right 3 to create new points. So 1, -3, up 4, right 3, up 4, right 3. Of course, you could go down 4, left 3 as well. So that's it for our lesson on graphing lines. Thanks so much.